All right, guys, welcome back. So what we're going to do in this video is talk about partial fraction integration. And this kind of helps us with a question for integrals that look like this. So how do I do the integral of 1 over x squared minus 16? So kind of a fraction like this. How would you integrate it? And that's what partial fraction integration is going to help us solve. So the first thing we're going to do today is learn about algebra. So we'll save the calculus for the end, but we're just going to do some algebra and partial fraction decomposition. And what this is basically we're going to break a larger fraction into two smaller ones. So we're going to take a larger, more complex fraction and turn it into smaller ones. So for example, let me demonstrate this by saying we're going to try and break the fraction 6x minus 19 over x plus 5 times x minus 2 into two fractions. So this is the decomposition. This is kind of the precursor to doing calculus. So what we're going to say is okay, 6x minus 19 over x plus 5 times x minus 2 is equal to some fraction a over x, or some constant a over x plus 5 plus some constant b over x minus 2. And our goal is to find a and b. So basically what we're doing is we're doing the opposite of a fraction addition. We're saying that there are two fractions which add to 6x minus 19 over x plus 5 times x minus 2. What are those fractions? Okay, now, and that's what we're going to try and solve. We're going to walk through that now. So the first thing we're going to do is we're going to multiply each term by the common denominator. So we're going to take each term of this. We want to get all the fractions out of this equation. So we're going to multiply everything by x minus 2 times x plus 5, x minus 2 times x plus 5, x minus 2 times x plus 5. Okay, so on the left side, we can see everything cancels. So we're going to get 6x minus 19. On the right side, the x plus 5 cancels. We have a times x minus 2. Here, the x minus 2's cancel, so we get plus b times x plus 5. So at this point in time, we see 6x minus 19 equals ax minus 2a plus bx plus 5b. Okay, so now there's a way to solve for a and b, and I want to kind of show you just as like a side calculation what's going on. Now, if I tell you that we have some equation ax plus b, and that's the same as the equation 3x plus 7, I think we can look at this and say, okay, well, I can line up the slopes. If those two equations are the same, the slopes have to equal, so a is 3, and I can line up the constants, so b has to equal 7. I'm going to do the same thing here. So I'm going to line up the constants, and then I'm going to line up the x coefficients to get a system of equations. So I'm going to get two equations here. One is I'm going to line up the constant. So if I underline the x's. So if I underline the x's, I get 6 equals a plus b. Now, that's what I got. Now, if I go ahead and underline the constant terms here, so the terms without an x in it, I get negative 19 equals negative 2a plus 5b. Okay, and now once I have this, so I got one equation for the x's, one from the constants, now my goal is to solve the system to help me find a and b. Okay, so you can use substitution, you can use elimination, you can use whatever your favorite strategy is that you use in Algebra 1. I like substitution most times, so let's just say a equals 6 minus b. And then if I substitute that in, I get negative 19 equals negative 2 times 6 minus b plus 5b. So let's solve that out. So I'll get negative 19 equals negative 12 plus 2b plus 5b. If I add 12 to both sides, I get negative 7 equals 7b. So my b is negative 1. And of course, if I plug that back in here, I get a equals 7. Now, that's great, because that's what we wanted to do. We wanted to find those constants a and the b, so we could write it out like that. So the a went over x plus 5, so that's going to be 7 over x plus 5. And then the b went over the x minus 2, so minus 1 over x minus 2. And this is our answer. This is what we were attempting to do in this problem, was take this more complicated fraction and then break that up into two smaller ones. And again, this is easier for us to work with, and that's the goal. So let me give you one to try. So I want you to split apart the fraction 4 over x squared minus 6x. And hopefully, x squared, sorry. Hopefully you see that the first thing you need to do is to factor the bottom. So go ahead and pause the video, factor the bottom, and then try and get as far as you can here. Okay, so this is 4 over x times parentheses x minus 6. So what that is that is equal to sum a over x plus sum b divided by x minus 6. Okay, so what that means, again, we'll multiply, and by the way, if you flip these, if you put the a over x minus 6 and the b over x, it actually doesn't matter. It'll work out the same in the end. So now let's go ahead and multiply everybody by x times x minus 6. So on the left side we get 4, everything cancels, equals a. Here, the x's cancel, so we get a times x minus 6. And then here the x minus 6's cancel, so we get b times x. So when I write this out, I get 4 equals ax minus 6a plus bx. Now when you look at this, don't be flustered, right? There are no x's on the left side, right? There's nothing there. So it's like having a 0x. So the equations that we have to work with here are 0 equals a plus b. That comes from the x terms. And then we get another equation here. Oops, let's pick a different color. The other equation comes from the constants. We get 4 equals 6a. Now, in this case, it worked out really nicely because they just gave us the a right here. So a is 2/3. You can plug that in. So my b is negative 2/3. So that means that we can break this fraction up to be 2/3 divided by x plus negative 2/3 divided by x minus 6. Now again, if you just pick the a and the b, like you put b over x, a over x minus 6, you'll get the same answer. The terms are just backward. It doesn't matter. Same. Okay, so that's it. So now let's go ahead. That was algebra. Now let's do some calculus. So now we're going to use integration by partial fractions. And there's really one specific case that you're going to use. So you're going to use this when the denominator can be factored and I guess that we can say the bigger power is on the bottom. You can actually use this partial fraction sometimes if it's the same, but you generally are going to have a bigger power on the bottom is one tip that you're going to use partial fractions, and the bottom can be factored. Those are the two keys. So if you can factor the bottom and you see the bigger power on the bottom, that's the time to use partial fractions. So for example, suppose we have to integrate 0 to 1, so we'll do a definite integral, of 6x minus 4 divided by 2x squared minus 5x minus 3. Okay, so the first thing I'm going to try and do is see if I can factor the bottom. 2x squared minus 5x minus 3. I don't know how you learned this when you were in Algebra 2, but the way, or Algebra 1, I guess. I made a little x, so I do 2 times minus 3 is negative 6, and then the negative 5 in the bottom is negative 5. So then I want two numbers that add to negative 6, or sorry, multiply to negative 6, and then add to negative 5, so that's like negative 6 and positive 1. And then because it was a 2x squared, what we do is we divide this by 2, divide by 2, so that's like a negative 3. So you have an x minus 3, and the other factor is a 2x plus 1. Okay, so what that means is you're integrating 0 to 1 of 6x minus 4 over parentheses x minus 3 times 2x plus 1. If you're having trouble factoring things like this, just make sure we can talk about it in class. That's no problem. Okay, so now, once you've rewritten in the factored form, what we're going to do is all the algebra first. So we're going to split this up, then integrate as a last step. Okay, so I'm going to say 6x minus 4 over x minus 3 times 2x plus 1 is equal to a over x minus 3 plus b over 2x plus 1. I'm going to go through this pretty quickly because you just did this twice. So everything gets multiplied here by x minus 3 times 2x plus 1. So the left side we get 6x minus 4 equals a times 2x plus 1 plus b times x minus 3. So I get 6x minus 4 equals 2ax plus a plus bx minus 3b. So when I set up my system, I have a 6, a 2ax, and a bx. So 6 equals 2a plus b. And then I'll circle these. So negative 4a minus 3b. So negative 4 equals a minus 3b. All right. Well, again, you could use substitution elimination. It doesn't matter. So your a is equal to 3b minus 4, so we'll plug that in. So that tells me that my 6 is equal to 2 times 3b minus 4 plus b. All right, so I got 6 equals 6b minus 8 plus b. So I end up getting 14 equals 7b, so my b is 2. And then if I go back here, a is 3b minus 4. Oh, my a is 2 also. That's cute. Okay, so now that I've done the decomposition, and again, feel free to pause and work through that yourself if you're struggling with that. So I'm going to rewrite the integral. So I'm going to rewrite the integral as the integral of, okay, so my a went over x minus 3. So 2 over x minus 3 plus, and then my b went over what? 2x plus 1. Okay. Now, the tip I want to give you here, and we're still integrating this from 0 to 1, but basically what you want to do on these is just integrate each part separately. Just, deal with this integral. Integrate each part separately. And by the way, in pretty much every case, you're going to need to do a u sub on these. And then I'm going to plug in the bounds. Okay. So on the first part, my u equals x minus 3. I'm just going to plug in the bounds at the end. I'm not going to change them here. The du is just dx, of course. That's just 2 over u, so that becomes 2 ln of x minus 3. Definitely be careful with the u sub here, because here your u is 2x plus 1, so the du is 2 dx. So this actually just becomes integral 1 over u du. So this just becomes natural log of 2x plus 1, because that constant 2 just went away. Okay, now, if it were an indefinite integral, you just slap a plus c on the end, you're good. In this problem, we're just going from 0 to 1. So we'll plug in the 1 first. I just plug in the 1 to the whole thing, the 0 to the whole thing. So when I plug in the 1, I'm going to get 2 ln 1 minus 3 is 2 ln 2 plus the ln of 3. And when I plug in 0, I get 2 ln of 3 plus the ln of 1. Okay, and that's fine. You don't need to simplify. That's how you do these problems. So again, we do partial fraction decomposition to kind of break it into the two parts. And that broken into two integrals that we could kind of easily handle with u subs. And then that was the approach. We u sub both, we plug in the bounds, and we're good to go. Okay, so that's partial fractions. Bring me some questions to class, and thanks for watching.